Hello, everybody. Welcome to another IoT Meetup, this time on the Apache PLC4X project. My name is Hudson Kelly. I'm with the Eclipse Foundation, and we are lucky today to have presenting to us Christofer Dutz he's a senior software engineer at Mapped and the Apache project vice president. At this point, I'll hand it over to you, Chris, and take it away.
Hi. And thanks for having me. It's always a pleasure to talk to people I haven't before. I've seen some usual suspects on the list, but I hope that for most of you, this is going to be something new and interesting. So let us get started. I'm going to be talking about building bridges. Initially, when I started this project, I'm going to be talking about, it was building bridges in the industrial automation, but today I also want to maybe trigger some building of bridges to the Eclipse Foundation or the Linux Foundation, maybe. So first of all, who am I? My name is Christofer Dutz. I'm a senior software engineer for a company called Mapped. I'm a total open source enthusiast. Since my first email to an Apache list, I think that was 1999, most of my free time has gone to multiple open source projects. I think at Apache, I'm currently committer in 11 projects. I think it might even now be 12. And outside of the ASF, I think there's a big number of projects I've contributed to. I'm a member of the Apache Software Foundation, and I'm currently serving as vice president of the Apache PLC4X project. I've got my Twitter and LinkedIn here if you want to follow what I'm doing. So let's just jump into the action. So, in the past, we're talking about Industry 4.0, but just in case you wanted to know what actually, well, if there's a 4.0, there must have been a 3, a 2, and a 1. So from today's perspective, usually people say that Industry 1.0, that was when we switched from human labor to water and steam-powered energy sources to mechanize production processes. Industry 2.0 is generally thought of when we switch water and steam to electricity. The biggest thing probably was, the most interesting part from my perspective, because I really love steam engines, but Industry 3.0, that was when we started stopping to use wires and cables and electrical parts to build sort of our automation and started using PLCs, IT infrastructure, and computers to automate our machines. So the thing is, Industry 1.0 and 2.0, the production hardware, well, let's call it hardware, was pretty universal. You generally had something that turned something. Yeah, it doesn't matter if it was water running over a mill and that turned some cables and they powered our machinery. Later on, it was a steam engine that did that. But the thing was, it was pretty universal. It was pretty unspecialized. Everything that these energy sources did, they would just turn things. And they were compatible with each other. So if you had a mill that was water powered, well, you could just replace that with a steam engine. So it was a pretty sort of universal way. So talking about, let's say, continental drift-like, Industry 1.0 and 2.0, that was this time of Pangea. I don't know if you pronounce it in English that way, but in Germany, we call it a Pangea. Everything was sort of one big landmass. It was easy to go everywhere from every point. But things changed when we switched to Industry 3.0. We started having specialized hardware. We had vendors that established complete product ecosystems. They all were developed independently, so it wasn't like today when vendors join forces to create something new. No, in those times, everybody developed his own stuff, and it worked perfectly with his own tools. They were very specialized, all the tools that a vendor produced, they could only they were built to communicate with the products of that same vendor. So the only exchangeability you had was with the products of the vendor you were bound to. So if you, for example, had decided to go with Siemens, if one of your PLCs died and you replaced it with another one, or it was just replaced because it was time, you could just get another PLC from Siemens, and you could expect everything to work fine. But the thing was, you didn't quite notice, but you entered a complete vendor lock-in. So if you decided to go with one vendor 20 years ago, you couldn't just sort of drop everything and just go to another vendor, or even start migrating. So if you wanted to get that one machine from that other vendor, you could, but you just couldn't integrate it into your system. So with Industry 3.0, we sort of have more of this picture of the world today. We have little islands, pretty big islands, but in the end, they're islands. You can't go everywhere just by foot. You have to invest time for ships, planes, whatever you want, but you can't just go anywhere anymore. You're now sort of stuck to the island that you decided to live on, or you were born on. So in the current situation, we're talking about Industry 4.0. It doesn't matter how you see it, but in the end, it boils down to Industry 4.0 is all about the data. And in production, data is everywhere. I don't know if you can imagine the amount of data that a modern production line produces. In one example that we did, the company was planning on pumping 26 gigabytes of data per second, because they wanted to get 2,600 data points from every PLC they had. And that is quite a bit of information. And probably you can do quite some interesting things with it. But the problem is, just because the data is there, it doesn't mean you can get to it easily. If you've got a new PLC, let's say the last 1 or 2 years, it's probably a pretty easy thing. If you're lucky, you've got OPC-UA or MQTT on it. If you're not that lucky, you have to go with something called Modbus. But accessing data on older PLCs is really hard. And as I mentioned, I like to compare Modbus sort of like with Grandpa. Sort of like, everybody has one. I don't think I have a single PLC that doesn't talk Modbus. It's sort of nice having him hang around, because at least there's some way you can get to your data. But usually he's not so useful for very quick actions or heavy loading. And that's the same problem with Modbus. If you just want to get 1 or 2 bits of information, it's good. But if you really want to get a lot of data, especially the volumes you need for machine learning and stuff like that, you don't get far with Modbus. But the thing is, I now mentioned OPC-UA, MQTT, and Modbus. But the thing is, in the past few years, whenever I attended any talk, and I was searching for some slides on the internet that sort of helped me underline this. So here's, for example, a slide I found from an Eclipse IoT project. And there they mention, they can get data, from Modbus, OPC-UA. We can get data from everything. But things have changed a little, so more and more other connectors have been added. But generally, these are the three ones I can see in almost every talk or every new platform that comes up. Let's go to an example of Hortonworks. Here they also mention MQTT, OPCOA. They don't even mention Modbus. Search for Apache projects. I think this was from a slide about MXNet, because well, in the past we've done some cross-pollination. So most IoT-related projects at Apache do support accessing machines and different protocols. The Eclipse, the Linux Foundation with their EdgeX Foundry, well, usually they say, well, you can see here machine data. Well, we've covered that with OPCOA. Well, sensors. Well, we've covered that with Modbus. And yeah, well, let's say some hipster scale. Well, we'll use MQTT for that. But the thing is, that's not enough. And for me, it sort of like felt like they were building these really cool ecosystems. And for me, it always felt like, yeah, we do all the cool cloud stuff. Well, getting the data, that's easy. Actually, it's not. Because the current situation, if you've got a production line as well, you've got a lot of different machines. As you can see in this picture, well, it's certainly not a real machine, but well, I think you get the point. There are a lot of different parts in such a production line. There are all sorts of types of machines. They might even come from all sorts of vendors. Just because one company is great for building robot arms, well, they might suck at or don't even produce things for cutting material or doing welding or whatever. Production lines, usually, well, if you build them, they've all got usually new machines, but over time things change. Factories get retrofitted, so you've got old machines, you've got new machines. So if you sum that up, you've got a lot of different ways to communicate with all of this hardware. As I mentioned, accessing data on PLCs that are older than 1 to 2 years old is pretty difficult because we don't have just a bunch of protocols. We've got hundreds of protocols. And just because two machines speak the same protocol, it doesn't even mean that they are able to exchange information. They might be implemented with little differences. As I mentioned, Modbus, for example, there are Modbus implementations that send their data big endian, and others do it little endian. Yeah, so both of your machines can talk to each other, but, well, they don't speak the same language. Another thing is, just because you've got a PLC and you've got the means to access it, they usually have no or bad security. So you would never, ever want to connect a PLC to the internet, because if you do that, well, you're screwed. Even if a PLC supports, for example, OPCOA or Modbus, you might not be, you might be able to access the machine, but you might not be able to access data in that amount that you want. In that one example where we did a proof of concept, there was the customer wanted these 2,600 data points every 2 seconds. And with the OPCOA, they were actually only able to get 200 data points per second. If they went above that, the machine just shut down, because these PLCs, they are no high-end servers that are able to do enormous amounts of calculations. Doing protocol stuff really wears them out. And usually as soon as they reach a certain level, well, they just stop working. They just shut down and say, yeah, sort of, I'm overloaded, please just let me alone. OPCOA was improved, I think the last year. Companies started shipping first versions of OPCOA that support a pub-sub mechanism. That is a lot better. And it's pretty similar, I've been told, to MQTT. So in the end, MQTT is right now, if you've got new stuff and you want to do the fun stuff with it, well, for me, MQTT is the only real alternative at the moment. But the thing is, just because those protocols are available, it doesn't mean that you can expect them to be present in your factory. This little chart, it's a little outdated because the newest one I found was from 2019, but usually things don't change that much from one year to the other, even if, well, you can see I don't even have MQTT or OPC UA because at that time so little were sold that probably it's sort of like running in other Ethernet. So it wasn't even mentioned explicitly. And the thing is, industrial hardware is usually built for lifespans of, well, let's say up to 20 years. And you can imagine when MQTT and OPC UA enabled PLCs are available for the last 1 or 2 years. Well, if we just assume that every PLC built into machinery in the last 2 years supports at least one of them, well, then, 5% is exchanged per year. That gives you a total of a maximum of 10% availability. And those numbers are sort of a little bit high because I think end of last year, there were some numbers that 75% of all vendors had, for example, OPC UA enabled devices. And other numbers were that 25% of all sold PLCs were OPC UA enabled. So just because they had OPC UA products didn't mean that they actually sold those. And probably less than these 25 had it enabled because if I take, for example, a Siemens S7 device that is usually OPC UA enabled, but you have to pay extra money to actually enable that interface. And that's sort of 400 euros, I think, per device. So a lot of people might even just say, yeah, well, I'll pass on that. So we're missing something because, well, we've got all the cool stuff with which we can talk to all the new devices, but, well, 90% of our devices aren't new stuff. We also need ways to integrate systems of different vendors. This whole vendor lock-in thing, it's sort of like keeping us from real innovation. And we need a way to do this without spending hundreds of thousands of dollars. In the past, I've been at several companies that introduced commercial, industrial integration platforms. And well, if you start with these, you really have to pay a few $100,000 in license costs, because I think the cheapest one just starts at $100,000 or something like that. And well, if you need a system that performs really good, well, you have to sort of multiply that by a few. So that doesn't seem to be a solution. And as I wanted to do Industry 4.0 applications, well, I was in need for something that could help with this problem. And that's where this project comes in. Luckily, my last employer let me work on building a universal API gateway for 3 full years. And this work, after 2 months, we joined the Apache Incubator. And 1.5 years ago, we finally graduated to top-level project of the Apache Software Foundation. And, well, PLC4X is a set of library for communicating with industrial hardware. Not just PLCs, but also protocol-enabled sensors or other machinery. But the key point is it doesn't matter which protocol you use, they all share the same API. And I think that's one thing I haven't come across with any of the other projects, this uniqueness of the API. this allows you to do some really cool stuff. It allows you writing software for any type of PLC. If you ever decide to switch the types of PLCs, well, all you need to do is just update the configuration. Usually with commercial drivers and stuff like that, or even open source drivers, the driver usually dominated how you have to write code to use that driver. So you couldn't just replace one library with another library and expect things to keep on working. You really needed to sort of rewrite your application from scratch. With PLC4X, it's really easy. You just drop in the new driver, change the configuration, and you're ready to go. And this helps in a lot of situations. For example, one company that was using PLC4X, they had, I think, factories in, 18 factories all over the world. And all of them were using Siemens as automation hardware, all except the ones in the US. Because in the US, I think I don't know if they were Schneider Electric or Allen Bradley controllers, but the thing was, the machines were doing the same things, but they were just using different controllers and different protocols. So in the end, with PLC4X, they were able to write the same software and just update the configuration for the US factories, and they could just continue going. One of the biggest things we've been working on in the past 2 years was a framework for code generation, because PLC4X is called PLC4X and not PLC4J, because we strongly believe that writing drivers isn't that difficult. If you understand how the protocol works, it should actually be a pretty simple task. So what we worked hard on was creating a way with which you can define the way how a protocol communicates and then just have the code generated. So we've currently got a strong number a strongly growing number of protocols that we support. Sort of every month, 1 or 2 get added. But what's currently growing even faster is the number of programming languages we support. We also support features that protocols generally don't support. For example, I mentioned Modbus several times. That doesn't support publish-subscribe communication, so you can't sort of subscribe for value changes. But PLC4X abstracts, and with PLC4X, you can still subscribe, and what the driver does in the background, it just polls and simulates this subscription support. And one really big thing that we're working hard on is something called passive mode drivers. In this case, we're not able to actively read data from the network, but we're able to passively read everything that goes over the wire. So we've got our protocols, and they sort of like intercept a read request, and they get a read response. And all of a sudden, we know what a certain value on a PLC is at a given time without having to ask. And this is a really big thing, especially for an open source driver, because especially if you are dealing with machines that produce things for consumption by humans, the US FDA has very, very strict rules on security. And this actually would make it absolutely impossible for an open source driver to actively read data in such a secure network. With our passive mode drivers, we're actually able to do that. The cool thing is this code generation framework also speeds up the time we need to implement a new protocol. I think the last protocol I implemented, it took me a matter of days compared to months when I started writing the first drivers. And even implementing a new language, well, we're currently sort of talking about a few days till 1 or 2 weeks. And then we've ported our drivers to a new programming language. I'm sometimes looking over there to see if there are any questions, so don't be confused. Currently supported operations PLC4X supports is generally reading and writing of data. We support subscriptions. They can be cyclic subscriptions, so you just sort of like get a certain amount of data every 2 seconds or something like that, or on value change. So if you're only interested if a value changes, well, on value change is your friend. Also, PLCs have alarms. So if you want to react on a certain situation happening on your PLC, well, then alarms are your friend. I had just started working on the first modules for auto discovery just 2 days ago. And as soon as I'm progressing with the auto discovery of devices to find, well, I have these devices and I can use these protocols. Well, the next step is then to sort of like find out which information can I get from these devices. So I'm expecting to be investing a lot of time this year, well, okay, not this year, but next year, on discovery and browsing. The list of currently supported protocols, well, Siemens S7 was the first one. Beckhoff ADS, I guess probably in the US that's not that common, but in Europe, Beckhoff is one of the big players. Modbus, that's sort of very dominant in the Asian world, but as I mentioned, sort of every device speaks Modbus. In the US, I know that Ethernet IP has a lot more adoption. OPCOA, well, that's the new thing, that's worldwide. And the cool thing is, I think the OPCOA driver, that's the only one where we didn't sorry, I just got a question, which the difference between Siemens S7 and Siemens S7 TIA. I'll explain that right in a few seconds. For OPCOA, we're actually not implementing the driver ourselves, but we're using Eclipse Milo. So we're just embedding, we're sort of like wrapping a shell around the Eclipse Milo driver. Yeah, the other one, Fermata, KNXNet IP, CAN bus is the newest one that was just merged yesterday, I think. We did some work on Allen Bradley devices, and generally they just we haven't been able to finish them because we just don't have the core developers of PLC4X. We just don't have any devices that speak these languages. So we started working on them for proof of concepts or little projects, and they are as mature as we needed them for these, but we haven't managed to sort of like finish them. Yeah, and now let's, the difference between Step 7 and TIA is that Siemens implemented a complete new S7 protocol that sort of piggybacks on parts of the old driver, but that's the one that you need if you want to do the symbolic addressing in Siemens devices. Right now with the Step 7, we have to sort of disable this optimized field access in order to access data. And the problem with that is not that the protocol itself is difficult. I think we've got that pretty much covered, but the thing is, Siemens decided to calculate a hash, not for security reasons, because it doesn't really protect anything. Well, it does protect their own sort of ecosystem, because for an open source project, it would be impossible for us to produce a driver that has the logic for calculating these hashes without doing stuff that we weren't allowed to. And well, that's sort of what's keeping us from implementing that at the moment. Profinet, we have the specs, but we just didn't have the time yet to start working on that. Last year, when I did a lot of PLC4X talks, I usually explained this multilingual thing, but up till March this year, I think we didn't have a single implementation of anything working outside of Java. But that has changed. Now, PLC4X is a real multilingual thing. Right now, well, the first-class citizen is definitely Java. For Go, we've got a really nice API, and we just started porting drivers. I think the KNX driver and the Modbus driver are already ported. The code for BACnet and S7 are already ported, but we haven't built the driver logic around it yet. I'm currently working hard on C# and C, and the community is working hard on Python. The difference and why I wanted a PLC for C is that, well, let's say a Java driver, well, that goes up to multiple megabytes. I needed something really, really small to run on embedded devices. And I think last time I checked my S7 C driver, I think it was about 60K in total. So that's a size you can really use on embedded devices. But I have to admit, writing drivers in C, well, I think it's a little more fun than being stuck in lockdown, but I think there are not much things that I would say that are worse than writing drivers in C, at least for me. We already have a C++ API. Unfortunately, the people driving that, they sort of disappeared, I think 2 years ago. So we have the API there. I guess as soon as I'm done with code generation in C#, I'll probably also start whipping up some C++ templates for code generation. And just a bit more than a week ago, I got contacted by a company that was interested in porting things to Rust. So, well, let's see how that goes. So what's coming up? Well, first of all, now that we've got the code generation working, that's producing about 90% of the work. We still need to flesh out the protocol logic. That's usually not that much work, but we still have to do it manually. As I mentioned, discovery is going to be the next big thing, together with browsing of resources. Right now, let's say this passive mode thing, it's sort of an experimental feature. Not all protocols support that. We want to make it that all of the protocols support these passive mode drivers. Having just sort of moved out to new programming language, well, I am sure we still need to sort of mature the new languages a bit. Well, every now and then, well, we need to implement a new protocol. The next thing we really want to try is, up till now, we've implemented most protocols to be able to talk to PLCs, but we also want to start implementing fieldless protocols. It's not that we want to sort of replace PLCs and start making software PLCs. But the thing is, if you've got some industry machinery out there and you want to do some improvement, you might end up having to integrate, well, let's say, a vibration sensor or some temperature sensors. And well, if you now try using those typical Raspberry Pi level sensors, well, I think they might survive a week or so in a harsh production environment. After that, well, they'll just be dead. So you might be willing to get some real industrial grade sensors. And for that, well, usually you need fieldless protocols. We're really hoping that with implementing stuff like EtherCAT or Profinet, that we'll be able to retrofit existing machinery with new sensors without interfering with the original machinery too much. And well, that's the one thing we're always hoping on. I said, well, it's 10% of the work we still have to do manually. We're always thinking and discussing ways of how we can even stop doing that and start generating the whole logic. But I think that's still a bit of a path we have to go there. And what I especially really love doing would be to cross-pollinate with all those other open source foundations. I've been speaking at the Linux foundations conferences. I've been trying to reach out to the other foundations because you've got a lot of stuff that we just don't have. But also, we've got a lot of stuff that you actually need. As I mentioned, a lot of the presentations, they say, yeah, well, we've got Modbus, we've got OPC-UA, we've got MQTT. Well, we're ready to go. But yeah, well, in the end, you'll notice, well, you might need an ADS driver to get some really heavy load out of a backoff device. You will need an S7 driver to get performance data out of an S7 device, because with Modbus, well, it just doesn't scale. If we start working together, I think we could achieve really, really good things. So let me just, I did a little of brainstorming what I'd really, really love to do together with the folks from Eclipse. And well, the things I have on my wish list, so, well, it's Christmas soon, so, well, let's hope Santa brings me some of that. I'd really love to integrate PLC4X into Eclipse Cura. I think that's sort of a perfect match. I was recently made aware of Eclipse for DIAC. I think especially our code generation part could do really good things for DIAC, because well, with PLC4X code generation, well, you can generate 90% of the code you need to implement the client. But the cool thing is you get the server code for free too. So I think this we really should start a dialogue with these two projects. One thing a lot of people mentioned, which I would definitely not want to integrate PLC4X into, is Eclipse Hono. As it sort of lives in the cloud, I mentioned PLCs having non-existent security. I wouldn't really feel very well with sort of building something that you would even have the idea of connecting your PLC to the internet. That's the same reasoning why I will never invest time in implementing a JavaScript PLC for JS. Well, I'm not going to work on this because I think if we had something like that, just a lot of really bad things will start happening. We'll have websites that have direct access to PLCs just because it's so fun. So yeah, I think there are just some things you shouldn't do. And I think an Eclipse Hono integration fits perfectly to that. If you want to get your data into Hono, well, use Cura on the edge, and I think that's a really good setup. For this, I have learned in the past, because in the past, I built the integration modules in PLC4X myself. Usually it was, I thought something was very interesting, and I started contacting people, and they said, yeah, well, if you've got something, send a pull request, we'll merge that. But the thing is, usually I'm not that deeply into that framework. So I would sort of start implementing such an integration from a newbie perspective. And in the past, usually we found out as soon as some professionals come by, well, we scratch most of the code and do it differently. So I would really be helpful to sort of work on this together, that the people that know Cura or for DIAG or whatever other project comes there, I am more than willing to help with the PLC4X part if the others help a bit with the other side. So how can you all contribute in general? Well, it's actually quite easy. Sort of like the best thing, one of the best things you can do is start using PLC4X. If you use PLC4X, you'll discover things. Maybe it's sort of like usage patterns that we haven't thought of. Maybe you'll have hardware hardware setups that we haven't tested on because, well, we're no automation folks. I've got a little Fischer Technik factory behind me, but besides that, I don't have any hardware at my disposal. So we need feedback. Best way to get in touch with us is over our mailing list. That's dev@plc4x.apache.org. Everybody's welcome there. You can post if you subscribe first. Well, that happens like for every other Apache project by sending an email to dev-subscribe@apache.plc4x.org. If you found something, well, we're more than happy to get GitHub pull requests. But probably the best thing you could do for the project is start talking about PLC4X publicly. Because in the past, we had the problem, we did a lot of really amazing things. So we had a lot of proof of concept where we didn't sort of like just finish first in the race. Sort of, it was like having a brand new Ferrari compete with an old steam engine. I think the coolest thing was where we competed with a commercial industrial solution, and we outperformed that by a factor of 1,200. So we were 1,200 times faster than them. But the thing is, everybody in the industry is so totally scared about talking what they do. So usually when I came to a customer, well, they asked me, yeah, who's using it? And I say, a lot of people. So who's using it? Yeah, usually I have to say, well, there are a lot of people and we've done some amazing stuff, but we can't tell you who it was and we can't tell you what we did. So it's really difficult to sort of convince people if nobody talks about it. So if you want to sort of know what's going on in the project, follow us on Twitter. We tweet regularly. Yeah, so I hope I didn't sort of exceed my time limit. It doesn't look that way. So thank you all. I hope I was able to sort of give you some new triggers and new impulses. And I'd be happy to answer your questions if you've got any.
Thanks, Chris. And we do have a couple of other questions that were asked in the Ask a Question tab. One of them is there a mapping of OPC UA to MQTT 5.0?
A mapping? Can you elaborate a bit on what? You mean the data structures from OPC-UA to map them to MQTT messages?
I'm assuming,
probably, yeah, but let's say PLC4X isn't built as a bridge. It's sort of a library to build bridges. I think we recently added an OPC-UA server that allows you to start a software that acts as an OPC-UA server that in the backend connects to PLCs. So you can talk to an S7 device or some legacy device via OPC-UA using that. We're also thinking of porting what we have there to MQTT. So it would sort of be the same thing just for MQTT, but we haven't implemented anything for mapping from OPC-UA to MQTT. I guess you could use the MQTT server because, well, you can just attach an OPC-UA source to it. Yeah, but haven't thought too much about that.
Okay, and then another question is, why don't you add an MQTT driver so that you offer one-stop shopping for old and new PLC hardware?
Well, we already have sort of in our examples, we have this. We have some examples of how we can sort of just publish data to MQTT. But the thing is, MQTT is sort of, it's 100% this pub-sub concept. So it's not like you can sort of actively query for some information via MQTT. Well, you could probably build something that does that, but in general, it's sort of like a unidirectional data stream. And for that, we already have everything we need. It's just in the example. I think it's the Hello MQTT example.
Great, makes sense. And then just in the chat, a few have come in the last couple of minutes. So one was from Philip Struss. One is, are there certain MQTT brokers you typically see or you like especially working with?
Yeah, well, I have to admit, we've got a pretty tight sort of community relationship with the HiveMQ guys. And with them, we're already discussing Sparkplug support. So you can expect quite a bit happening on that side. Yeah, I think in the past we had we used PAHO in our examples, but we recently switched that to one of those HiveMQ libraries.
Got it. And then the last question, actually, there's a couple more questions. You're getting flooded here. One is from Tamberg in the chat, and I'm not sure if you've covered this already, but is there a unified information model? They missed a few slides.
No, there is not, because most of the protocols actually don't have that. And I have to admit, regarding these information models, I have to admit that was sold in the past as one of the coolest things OPCUA has to offer. But in the past, I've seen that the stupid thing with these models is, well, if everybody is using the same models, well, the machinery just talks to another without any configuration. But the stupid thing is every manufacturer seems to think that his model is different. So we've eliminated the protocol problem and just put another one on top. So like now we're talking about semantics. Now the semantics are different and incompatible with each other, and you have to do the translation all over again, just on another level. PLC4X is generally about the communication layer. Everything that you build on top of that, well, that's generally up to you.
And then as a follow-up to that, regarding the model, your library has a single interface, right? Yeah.
So you develop against a single API module. And I think you can sort of, if you've got experience, I don't know if any of you have experience with JDBC, native JDBC, not with some JPA wrappers around, the real pure JDBC. There you sort of submit a connection string and you get a universal API back that you can communicate with relational databases with. Well, it's pretty much the same way we have it in PLC4X. So you give the driver manager a connection string that has all the information it needs to connect to a device. It automatically finds the driver, uses that, builds up the connection depending on the protocol, and then you can just use the universal API to read no matter what protocol is behind it.
Thank you very much. And then one more question from Raphael in the Ask a Question tab. He says he might have missed something, but if he builds his bridge using PLC4X, what's the architecture and how many processes are there?
I beg, could you repeat that again?
Yeah. So in the Ask a Question tab on the bottom of the screen, Raphael is asking if he builds his bridge using PLC4X, what is the architecture and how many processes are there?
Yeah, well, it really depends on first of all, the language being used. Well, the C driver, it has just one process. If you use Java, well, there will be quite a bit more. If you use Go, well, there will be a hell of a lot more. The thing is, it really also depends on which features you use, because you can sort of created direct connection using our normal API, but we've also got tooling like a connection pool or a pool driver manager, a scraper, a tool that sort of automatically sort of scrapes information from various data sources. So if you use those, well, there will be more processes involved. I think if you just use a simple connection with Java, well, there will be one or two processes running internally and well, your application process, but it's not going to be overloading your system. Did that answer the question?
To me, yes. Raphael, if you have anything else, feel free to add that to the chat. Yeah, it sounds like Raphael is good. So I think that's it for questions. You still have a couple seconds, anyone in the audience, if you want to get one in. But at this point, I just wanted to say thank you, Christofer, very much for this presentation. A lot of good questions were asked, so clearly a very engaged and passionate audience. And yeah, thanks everybody, and enjoy the holiday season.
Yeah, so thanks from my side. I hope I didn't bore you. At least I tried getting this little pretty dry topic a little interesting. Yeah, and I'd be super happy to see the one or the other of you show up on our mailing list. Because I have to admit, the core team of PLC4X, well, it is very Europe-centric. Well, probably because I've been touring around Germany and greater parts of Europe a lot more than the rest of the world. And so I got more people on board in Europe, but I would really, really like to see the community grow on the other side of that little pond between us. Yeah.
Absolutely. All right, well, thank you, everybody. We're going to end the session now, so enjoy the rest of your day. Goodbye.
Bye.